Space holds a great many mysteries and riddles. Every day, scientists try to find something new, observing the processes in this dark abyss of the unknown. However, by observing ourselves from space, we can learn no less interesting information. This is Infinity, and in this episode, you'll find out how one photo from space explains the whole history. Satellite images of Earth's surface have become quite commonplace. Mapping services work in every cell phone. Continuous imagery today makes it possible to predict the weather with high accuracy, control fires and floods, conduct environmental monitoring of the planet, monitor deforestation, drainage of water bodies, and other processes. But satellite imagery of the planet at night is different from the usual photos of the Earth's surface. Traditionally, Earth is photographed from the side that's illuminated by the sun, but NASA's Black Marble shows the planet at night and illuminated only by artificial sources. The use of night images provides much more accurate and detailed information about objects that themselves are sources of light emission. This includes city lights, industrial objects, and other sources of artificial light. There's no interference from sunlight at night. This allows scientists not only to see more sources of electromagnetic radiation, but also to estimate their spectrum more confidently. That is, to make more accurate conclusions about the nature of the source. Collecting such statistics, it's possible to make a map of stable nightlights corresponding to stationary objects, cities, factories, volcanoes, and by studying changes in this map over a long time interval, it's easy to draw conclusions about infrastructural changes and link them to socio-demographic and economic trends, such as population density. From the first glance at the night planet, it's noticeable that it glows in an extremely heterogeneous way. In some places, the glowing city resembles a lone star in the night sky. In others, it's a dense cluster of galaxies. Navigable rivers are lit up in a surprising way. The Nile, for example, stands out strongly against the general background. Millions of people live on the banks of this river. A similar situation is observed on the Indus River in Pakistan. Also at night, we can see from space that humanity is still limited by natural landscapes. Just look at the area of the Himalayas, or for example, the area of Afghanistan. There are only a few large sources of light within the country. The main city's connected by a singular circular highway. Inside the circle, there's no light because the country is dotted with high mountains. It's also quite interesting to look at the territory of Argentina at night. The pictures clearly show the web of light sources that form the main transportation arteries of the country. The fact is that many cities in the country originally appeared as railway stations. To be sure of this, it's enough to superimpose the image from space at night with a map of railroad tracks of Argentina of the early 20th century. A similar pattern can be seen in Russia, where the Trans-Siberian Railway, which connects Chelyabinsk and Vladivostok, stretches for more than 8,000 kilometers. In addition, the night photos quite clearly reflect the problems of the modern world. For example, North and South Korea are sharply contrasted in the images. Besides, between Pakistan and India, you can see a thin, bright line, the state borderline, which was established in the middle of the last century when both states gained independence from Britain. The barriers and bright lights on it are designed to prevent smuggling and illegal trade between the countries. By the way, if you look at the U.S. territory, you can also see a clear division between the eastern and western parts of the country. But it's not about politics. The division goes along the 100th meridian. This is where the great difference in climatic conditions between the parts of the country begins. Theoretically, if you film Earth at night from space every day and analyze the momentary changes of stable nightlights over large areas, you can detect natural and man-made disasters, come to conclusions about emergencies, power outages, and other things. Moreover, this method can even be used to search for poachers in the ocean. The analysis of nighttime lights of marine vessels makes it possible to detect unregistered small watercraft, such as fishing boats, and to control the boundaries of area where fishing is allowed. The analysis of nightlights even makes it possible to estimate the amount of oil produced in a particular field. The fact is that during oil production, a byproduct is formed, the so-called associated gas. It's usually burned, and the analysis of the intensity of the flares burning in the field allows to estimate the volume of the burned byproduct and hence the volume of the produced oil. This makes it possible not only to monitor oil companies from an environmental point of view, but also to reliably determine the size of their production. Also, this method can be used to ensure the safety of people in seismically active regions. For example, Kamchatka and Kuril Islands have a huge number of volcanoes. They're scattered over a huge territory, and it's practically impossible to keep track of them all using ground methods. That is, with the help of seismic stations. Analysis of volcanic activity using night images allows us to predict volcanic eruptions with high accuracy. For example, in 2018, volcanologists predicted a volcanic eruption in one of the Kuril Islands using analysis of night images of the Earth's surface conducted at the Kurchatov Institute. Fortunately, this island is uninhabited, but if there had been settlements there, people would have been evacuated long before the eruption began. Watching mankind from orbit is quite fascinating, but it's much more interesting to observe space and its phenomena and processes. Stay tuned to learn the most incredible space theories and phenomena, as well as to see the planet called Earth's twin. Imagine a region in space into which not a single particle of matter can penetrate. It spews out incredibly powerful streams of radiation and shines with the power of thousands of ordinary stars. This is a white hole, the mysterious antipode of a black hole. Its concept first appeared in the 1970s, and astrophysicists never tire of working with it to this day. While the event horizons of a black hole prevents even light from reaching escape velocity, a white hole has this region as an absolute impenetrable shield. It's impossible to escape from a black hole, and it's impossible to penetrate into a white hole. If we imagine the existence of such an object in the real world, it would be an incredibly bright object, radiating energy into space with monstrous force. Until now, astronomers have never observed a white hole. Some physicists believe that such objects cannot exist in the real world. However, it's worth noting that until relatively recently, black holes were also only a beautiful theory. In fact, scientists have even found a phenomenon in the universe that can be explained by the existence of white holes. Its name is a gamma-ray burst. It's one of the brightest and most high-energy events in space. Dark energy. Scientists currently believe that matter occupies only about 4% of space in the universe. More than 26% is dark matter, but you can't touch that matter, and you can't see it through binoculars or a telescope. That's because dark matter is a type of mass that we can't see. All we know about is that it exists. This is evidenced by the gravitational effects it produces on other objects in space. The remaining 70% of space is occupied by dark energy. Scientists are not yet quite sure what it is, but it's this invisible force that they believe is the accelerating factor in the expansion of the universe. According to current calculations, for the first time after the Big Bang, dark energy was small due to the limitations of space. And then the expansion of the universe was slowed by the gravitational pull of dark matter. The situation was reversed about 5 billion years ago when the deceleration began to be replaced by acceleration. In a highly publicized article, Professor Lawrence Krauss theorizes that observing dark energy can shorten the lifetime of the entire universe. This is the result of the quantum Zeno effect, a quantum paradox according to which the observation of an object can directly affect that object. In other words, if we observe dark matter, we can thereby disrupt its internal quantum clock, which in turn can cause matter to return to an earlier form of its existence. Even today, it's difficult to imagine the scale of the universe. It is incredibly large. To measure its size, scientists use the redshift method. If an ambulance siren has ever whizzed past you, you're familiar with the Doppler effect. When the ambulance approaches, the siren sounds shriller, but when it moves away, the siren fades again. The same thing happens with waves of light, only on a smaller scale. Scientists can capture the change by analyzing the spectrum of light from distant bodies. The strongest redshift of light we can detect in the observable universe shows that the light came to us from galaxies that are 13.8 billion years old. During this time, the universe has been constantly expanding, and at first it did so very quickly. Taking this into account, astronomers concluded that the galaxies at the edge of the observable universe, which light has been coming to us for 13.8 billion years, must be 46.5 billion light years away. Things get even more complicated when scientists try to think about a universe that lies beyond the observable universe. That is, the whole universe. Scientists at Oxford University analyzed known data about objects in the observable universe to see what can be learned from it. The results led to new estimates. The whole universe is 250 times larger than the observable universe. Earth's twin. Since the launch of the Kepler Space Telescope in 2009, researchers have found about 4,000 planets outside the solar system, several dozens of which are possible twins of Earth, or are in the so-called habitable zone. One such place was the system K2-155, which is located in the constellation of Taurus and is removed from Earth by about 200 light-years. It's home to 3 super-Earths, the most distant of which, K2-155d, located in the central part of the habitable zone, and according to planetologists, it's the most similar to Earth in its characteristics. Scientists believe that the surface of the exoplanet may contain water in liquid form. The researchers have made such a conclusion thanks to a computer simulation based on the Kepler data and ground-based telescopic observations. According to a computer simulation, the K2-155d may also have an atmosphere, and climatic conditions on it may be similar to those of Earth. For more accurate conclusions, a detailed study of the planet will be required, in particular determining the exact radius and temperature of the nearest star. That's all, guys. Would you like to move to another planet? Let me know in the comments. Thanks for watching, and see you later.